This is Unit 3, Moles and Stoichiometry, Lesson 5, Determining Empirical and Molecular Formulas. How are empirical and molecular formulas determined? By the end of this video, you will be able to determine the empirical formula from the molecular formula, and you will be able to calculate the molecular formula from the empirical formula. Do now. So an empirical formula is defined as the smallest whole number ratio of atoms in a compound, which means it cannot be reduced any further. For example, if I have a B10G20 molecular formula, if I were to reduce it as far as it can go, the empirical formula would be B1G2. Another example, C2H6 is my molecular formula. If I can reduce the subscripts by the greatest common factor, then I will get CH3, which is the empirical formula. The molecular formula is defined as the actual formula. It's the actual number of atoms in a compound. It is a whole number multiple of the empirical formula. So for example, if the empirical formula is CH4, which cannot be reduced any further, a molecular formula could be CH4, C2H8, C3H12, etc. Notice each one of these different molecular formulas is a whole number multiple of the empirical formula. So for example, B1G2 is my empirical formula. A molecular formula could be B10G20. This is a whole number multiple of this. If I multiply 1 times 10, I'll get 10. If I multiply 2 times 10, I'll get 20. One more example, if I have the empirical formula CH3, a whole number multiple is 2. So if I multiply by 2, I will get C2, so 1 here. 2 times 1 is 2, and 3 times 2 is 6. Therefore, this could be my molecular formula. Here are a few examples. If I have a molecular formula here and the empirical formula here, the empirical is always the most reduced. It cannot be reduced further. So N2O4, if I divide both numbers by 2, I'll get NO2. C3H9, if I divide both numbers by 3, I'll get CH3. C6H12O6, if I divide both numbers by 6, all numbers by 6, I'll get CH2O. I'm going to write those numbers in so that it's a little more clear. Divide by 6. B4H10, if I divide both by 2, because that's a common factor, I'll get B2H10. C5H12, there is no common factor, so I cannot reduce this any further. Therefore, this molecular formula is also the empirical formula. So determining the empirical formula, all I need to do is divide the subscripts by the greatest common factor. For example, the molecular formula is C4H10. Divide everything by 2, which is the greatest common factor. So I'll get C2H5 is the empirical formula. Try these examples to see if you understand. Now check your work. I can also calculate the molecular formula from the empirical formula. Here are the steps we're going to follow. 1, I will first need to calculate the gram formula mass, remember our GFM from one of our previous videos, of the empirical formula. Divide the molecular mass given, so you'll have a mass given, by the empirical formula mass that you just calculated. 3, multiply all the subscripts in the empirical formula by that number, which is going to be a multiple that you calculated from step 2. So let's do an example, and I'll show you what that is. Oh, here's some work already done. The empirical formula for ethylene is CH2. Find the molecular formula if the molecular mass is 28.1 grams. So here I started to calculate the GFM. This will be the GFM of the empirical formula. So C and H are both the 2 atoms in my formula. I have 1 carbon and 2 hydrogens. I'm going to multiply by their masses. What are you doing? So carbon, I have 1 carbon. I don't know what's happening. Why are you doing this? I have one carbon. I'm not going to redo this. I have one carbon. The mass of carbon is 12. So 1 times 12 is 12. I have two hydrogens. The mass of hydrogen is 1. So 2 times 1 is 2. So I'm going to have 12 plus 2 is equal to 14. In order to find the multiple I need to multiply my empirical formula by, I'm going to take 28, my grams given, divided by 14. So 28 divided by 14 is going to equal 2. So I'm going to take CH2 and multiply each of these subscripts by 2. So my molecular formula will be C2H4. Here is that written out. So I apologize, I couldn't write that for you as I did it. So here's the empirical formula of CH2. 1 carbon times 12 plus 2 hydrogens times 1 is going to equal 14 grams per mole. Take that 28 grams per mole divided by the 14 grams per mole. It's going to give me a 2 multiple. Take CH2 times 2, and that's going to produce C2H4. This is our molecular formula. All right. Example 2. What is the molecular formula of a compound that has an empirical formula of NO2? So following our steps, I'm going to first calculate the gram formula mass of NO2. Then I'm going to take that mass and divide it by the mass given. And that will get me a whole number multiple that I will multiply each subscript by. So this is the math to show that. My drawing's not working, so I'll do it this way. So N, there's one N. So 14 times 1 is equal to 14. O, there's two O's, so 16 times 2 is equal to 32. So 14 plus 32 is 46 grams per mole. This is the GFM of the empirical formula. I'm going to take the mass given, 92 grams per mole, divided by 46 that I just calculated, and that's going to equal a multiple of 2. So I'm going to take my empirical formula, multiply by that factor, and get N2O4. Now you try, check your understanding. So you are now able to determine the empirical formula from the molecular formula, and you are also able to calculate the molecular formula from the empirical